you are welcome to Operation 4.0 online tutorials. Don't forget to subscribe, watch, share the link and leave a comment so that we can give you more. So today we want to look at how you can solve a system of equations using Cramer's rule. So you have been given, for example, these three equations. You are supposed to use Cramer's rule to solve. So the first thing you need to do to these equations is to cast it to what? Matrix form. So in order to cast this equation into matrix form, you need to ensure that all the variables are arranged in that particular order. So S1 in the first variable in the first equation should be S1 in the second equation. I mean that if S1 comes first in the first equation, it should be the same in the first in all the equations, so that you not do mistake while casting into matrix form. So after arranging that in that particular order, what you need to do now is to write all the coefficients of x1 in the three equations as the first column, coefficient of all the coefficient of all s2 as your second column, and then the coefficient of s3 as your third column. Or better still, you need to write the coefficient of all the three variables as your first row. You do same to the second one and to the third one. So, and this matrix that you have gotten here is what we call the coefficient matrix. And then you write all the variables as a vector matrix so that you can relate with it. And this is what we call the variable matrix. Then you have what we call the constant matrix. So we have done this well, and in order to solve this equation, you should ensure that your coefficient matrix, which is matrix A here, is a square matrix. And a square matrix just simply means that you should have the same dimension. So in this case, we have a 3 by 3 matrix. So the number of rows should be equal to the number of columns in order to solve this system of equations. So that's basically what we have. So next, we are going to look at how you can use Cramer's rule to solve this equation. What we are doing is to find the determinant of the coefficient matrix A. So you just write a straight line beside it and you watch into detail how we solve it using a step-by-step approach in our video. So just search YouTube on how to find determinant of a matrix from Operation 4.0 and you'll be able to relate with all of them. So we are finding determinant of the coefficient matrix. So the first element multiplied by the 2 by 2. When you do it well, you are going to arrive at 3. So quickly, let me show you how you can find the A subscript x1, A subscript s2 and A subscript s3, and then you find their determinant. Now it's just very simple. Look at your coefficient matrix and replace the first column in your coefficient matrix by your constant matrix. So our constant matrix, which is what a vector matrix, is 3, 0 and 6. So I'll replace 1, 1, 1 here by that. So my A subscript s1 is 3, 0, 6 instead of the 1, 1, 1. Then I'll write the rest of the elements 2, 3, 3, 5, 5 and 12. I'll do same for S2. The S2 now, A subscript S2 is that you replace the middle column by your constant matrix. So I'll do same 1, 1, 1, then 3, 0, 6, then 3, 5, 12. And I'll do same for 3. Subscript 3 is given by, I'll replace the third column. So 1, 1, 1, 2, 3, 5, and then now 3, 0, 6. So all you need to do now is to find the determinant of these matrices, and then you divide by the determinant of the matrix, the coefficient matrix we have found to be 3. So we are going to find the determinant of this particular matrix. From our A subscript S1, A subscript S2 and A subscript S3. So we need to find their determinant. So I earlier said that replace the first column, the elements there, by your constant matrix to get your A subscript S1. So that's what we have done here. So in order to find the determinant, you need to go through the processes of finding determinant of a 3 by 3 matrix, and you arrive at 39. So when you do that, now the Cramer's rule says that divide that determinant of the A subscript S1 by the determinant of the coefficient matrix. So we have gotten 39 divided by the determinant of the coefficient matrix, which is 39 over 3, and we'll get what? 13. So we'll do same for S2 and S3. So we'll go through the same process to find the determinant of A subscript S2, determinant of A subscript S3, divide it by the determinant of the coefficient matrix in order to find our solution. Okay, so we'll do same for A subscript S2. So we write it replacing the second column by a constant matrix. Now we have this, we find the determinant, and when you do it and do it well, you are going to get minus 33. And then S2 from Cramer's rule says that we should divide the determinant of A subscript S2 by the determinant of the coefficient matrix. You get minus 33 over 3, and you get minus 11. So we come to the third one as well. Now we are finding determinant of AS3, and I earlier said that we should replace the third column by the constant matrix. So we do that, we find the determinant of this particular matrix, and then we get 12. So now S3 from Cramer's rule, we can find it by dividing the determinant of A subscript S3 by the determinant of A, which is equal to 12 over 3 and equal to 4. So in conclusion, we can conclude that S1 equal to 13, S2 equal to minus 11, and S3 equal to 4. So we've been able to solve this system of equation using Cramer's rule, and we have done that, and I want you to refer to our video on how you can find determinant of a matrix so that it will help you. Don't forget to watch, subscribe, share the link, and leave a comment so that we can give you more. See you next time. Bye bye.